What if humanity is not the first to rise upon this world? What if the story of Earth has already written other chapters of intelligence, long buried beneath stone and silence? In 2018, two scientists dared to ask this unsettling question. Frank, an astrophysicist, and Gavin Schmidt, a NASA climate scientist, introduced what they called the Silurian Hypothesis. It was not a tale of fantasy, but a sober inquiry. If an industrial civilization had flourished millions of years before humans, what evidence would remain? The name itself was borrowed from science fiction doctor who Silurians imagined. Reptilian scholars of an ancient world, yet behind the playful reference lay a profound seriousness. Their proposal was not about dragons or myths, but about geology, climate, and the way civilizations etched themselves into the planet's memory. They asked if another species once harnessed energy, altered landscapes, and left behind an industrial fingerprint, would we even know? The timing of their question was no accident. Humanity itself stands in the Anthropocene, an age where our collective impact is written into the rocks, plastics, isotopes, warming seas. Our civilization is already leaving scars that future geologists will find long after cities crumble. And so, by turning the gaze backward, Frank and Schmidt wondered, could such scars exist deep in time, concealed within layers of ancient Earth? This was not speculation for entertainment, but a test of our assumptions. It forced science to confront the immensity of deep time, where continents drift, oceans rise and fall, and almost everything vanishes. Against such a backdrop, the question becomes more haunting. If we are not the first, how many worlds have already been forgotten beneath our feet? Time is not gentle. It does not preserve. It erases. The surface of Earth is not a library of memory, but a restless ocean of change, forever rewriting its own pages. To peer into geological time is to face a truth that unsettles even the most patient minds. Nearly everything vanishes. Human civilization. With its cities of glass, its monuments of stone, and its satellites adrift in orbit, feels immense in the present moment. Yet in the scale of Earth's chronology, it is no more than a flicker. Recorded history itself, the span of writing, culture, is permanent, and memory is a thin blade of light stretching back just 5,000 years. Even if one extends the human story further, to the earliest cave paintings and tools of stone, the tale grows no longer than perhaps 300,000 years. For a planet that measures its age not in centuries, not in millennia, but in billions, it's nothing. Earth's story is 4.5 billion years old. Its continents have wandered like restless giants, colliding, splitting, and drowning beneath seas. Mountain ranges once as tall as the Himalayas have been worn down to whispers of rock. Oceans have drained and filled, forests have bloomed and burned, deserts have marched across entire hemispheres. To walk across the surface of this planet is to walk on the ruins of countless forgotten worlds. And here lies the shock of deep time. If another civilization had once risen long before us, an intelligence that built, consumed, and altered its environment, the odds are overwhelming that we would never know. Their cities would be ground to dust, their monuments tumbled into sand, their machines dissolved into ores. The shifting crust of the earth would bury them, recycle them, or swallow them back into the mantle. After millions of years, almost nothing remains. The fossil record itself proves this fragility. Consider the dinosaurs, rulers of Earth for more than 150 million years. They filled every niche: predators, grazers, giants, and flyers, and yet their remains are rare jewels in stone. Out of the countless trillions that lived, only a fraction left fossils, and fewer still were discovered. If the bones of titans can vanish, what chance would the skeleton of a city have? The gaps in the fossil record are not accidents, they are the nature of the record itself. Paleontologists describe this as the pull of the recent, where younger layers of Earth preserve more evidence, while older epochs are scarred by erosion, metamorphosis, or destruction. Go back beyond a few million years, and the traces of soft-bodied creatures grow scarce. The remains of entire ecosystems erased. Now imagine a technological society lasting perhaps a few 100,000 years longer than our own has yet endured, but still the blink of an eye in geological terms. Its artifacts, unless buried in extraordinary conditions, would vanish. Skyscrapers would collapse, rust, and dissolve. Highways would be consumed by roots and floods. Even plastic, that most enduring of human inventions, would eventually break down into microfragments, diffuse into sediments, too chaotic to recognize as anything but unusual pollution. And what of monuments carved in stone? Even they are not immortal. The pyramids of Giza, magnificent as they are, have stood for less than 5,000 years. Give them 5 million, and the winds will grind them flat. 10 million, and tectonic shifts may bury them beneath rising seas or mountain chains. 100 million, and they would be gone entirely. Their story reduced to crushed minerals in some anonymous layer of rock. This is the scale of Earth's forgetfulness. The surface is not a permanent archive, but a restless stage, sweeping away. It sets and rewriting its play with every age. Evidence of an ancient civilization, should it exist, would not present itself in the way human memory expects. It would not appear as fossilized cities, frozen machines, or monuments waiting patiently for discovery. Instead, it would surface only as chemical scars, isotopic signatures, or sudden changes in climate locked into the stone. And yet even those scars are difficult to read. The geological record is a puzzle written in fragments, and much of it is missing. Entire layers of Earth's crust have been subducted back into the mantle, recycled into molten rock, their memory erased forever. Vast regions of ancient continents lie hidden, transformed into metamorphic stone that no longer remembers its origins. What we have is a patchwork, a scattering of windows into the past, each one incomplete. To confront this is to realize that true terror of deep time, absence of evidence, is not evidence of absence. The fact that we see no cities in the rocks of the Cretaceous, no machines in the sands of the Paleocene, no monuments in the Permian, does not mean they were never there. It only means that Earth has done what it always does: obliterate, recycle, and forget. Consider, too, the extraordinary accidents required for fossilization. A creature must die in the right place, under the right conditions, its remains buried quickly, shielded from scavengers, decay, and erosion. Even then, the odds remain slim. Multiply this improbability by the fragility of artifacts compared to bone, and the silence of the record becomes less surprising, more inevitable. If humanity vanished tomorrow, what would remain of us after 100 million years? The traces most likely to survive would not be our cities, but our chemistry. The sudden spike of carbon dioxide from fossil fuel combustion, the strange isotopic ratios left by nuclear weapons testing, the long-lived molecules of plastics, pesticides, and industrial compounds diffused into soil and sea. These are the kinds of fingerprints that might persist, faint but detectable, in the rock. And so the question shifts. When scientists search the record of Earth, do they find anomalies? Are there moments in deep time where chemical signatures shift abruptly? Where climate tilts with unnatural speed? Where extinctions surge without clear cause? The answer, unsettlingly, is yes. There are chapters of Earth's history where the climate warmed suddenly, carbon spiked, oceans acidified, and ecosystems collapsed. Some have natural explanations: volcanoes, impacts, tectonic upheavals. But others remain less clear, leaving open the haunting possibility that they are the scars of something more. The Silurian Hypothesis does not insist that civilizations came before us, does not claim that reptilian scholars once built empires in the Devonian, or that mammalian engineers thrived in the Eocene. Instead, it asks us to recognize the humility demanded by deep time. It reminds us that Earth's memory is fragile, that its silence is not proof, and that the absence of monuments does not guarantee the absence of builders. To imagine that humanity is the first and only is comforting. It places us at the center of history, the pinnacle of evolution, the sole intelligence to ever walk these lands. But to peer into the abyss of deep time is to admit a darker, more humbling truth. Perhaps there were others, long forgotten, erased not by malice or catastrophe, but by the patient indifference of a planet that rewrites itself with every age. And so the shock lingers, and just heavy and unshakable. If Earth can erase entire empires of dinosaurs, if it can grind mountains into dust and oceans into deserts, then what chance does a civilization truly have to be remembered? Humanity, for all its pride, may one day join the same silence. Story may vanish, just as any story before us did, leaving behind only the faintest of whispers in the stone. The Earth remembers, but not in monuments, not in ruins, not in the sharp lines of architecture. Its memory is written in chemistry, in layers of stone pressed and folded over eons. If civilizations vanish, if their towers collapse, and their machines dissolve, what remains is not the image of their world, but the fingerprint of their impact.
Oh.
The rocks become the diary of the planet, and in that diary, we search for scars. Scientists ask a sobering question. What will remain of us in 100 million years? Cities will not. Skyscrapers will tumble. Bridges will rust. Satellites will rain from orbit and vanish into oceans or soil. Even the pyramids, eternal in the imagination, will be ground to dust by the patience of wind and water. But chemistry endures. The most enduring trace of human civilization is plastic. Born barely a century ago, it now saturates the oceans, rivers, and soils of every continent. From remote Arctic ice to the deepest trenches of the Pacific, microplastics drift, as silent witnesses to our era. Over tens of millions of years, these fragments will not remain whole. They will shatter, degrade, and mix with sediments. Yet even broken, their molecules may persist, fossilized within strata as tiny chemical anomalies. A future geologist, digging into a cliff face, might find an ancient layer laced with polymers no natural process could have produced. To them, it would be a whisper from a vanished people. Alongside plastics are the isotopic scars of industry. It's the burning of fossil fuels has shifted the very ratios of carbon in the atmosphere. Normally, Earth maintains a delicate balance between carbon-12 and carbon-13. But the coal, oil, and gas we consume are rich in lighter carbon, drawn from plants that lived hundreds of millions of years ago. By releasing them back into the air, humanity has tilted this ratio sharply a signature that will sink into rocks, soils, and shells, marking the Anthropocene with unmistakable clarity. Millions of years hence, if another intelligence studies Earth's sediments, it will see this sudden skew. It will know that something extraordinary happened, something unnatural in its speed and magnitude. Fertilizer, too, leaves its mark. Humanity's vast expansion of agriculture has released torrents of nitrogen into rivers and seas. This shift, visible already in sediments, will fossilize as a chemical spica, sudden bloom of nitrogen compounds embedded in stone. No volcanic eruption, no asteroid strike, no natural process replicates this exact pattern. It is the fingerprint of an industrial species feeding billions. There are other scars. The radioactive isotopes, born in nuclear tests, rare and unstable, may decay with time, yet some of their daughter products endure. Future ages may find in rock an unnatural sprinkling of these isotopes, marking a moment when a species split. The atom. Even if reactors and warheads turn to rust, the chemistry they unleashed may outlast their makers. And perhaps most telling of all are the extinctions. Humanity is driving one of the greatest die-offs in Earth's history. Species vanish at a pace far beyond the background rate of evolution. Coral reefs bleach and collapse. Forests thin. Mammals shrink in diversity. This sudden pruning of life will not pass unnoticed in stone. Future layers may show a sharp break, a moment when countless species disappear, replaced by a smaller, narrower world. Mass extinctions are time's loudest alarms. Humanity has already set this one ringing. If these are the markers of our age, then by symmetry, they are the markers we must search for in the past. If another civilization once rose and fell, its memory will not come as ruins, but as geochemical oddities and anomalous ratios of carbon, nitrogen, oxygen, layers of stone infused with synthetic compounds, sudden die-off of species coinciding with chemical spikes. These are the fingerprints of an industrial age, whether human or something far older. And so scientists turn their gaze to ancient anomalies. Among them, one epoch stands out: the Paleocene thermal maximum 55 million years ago. It was a moment when Earth's climate lurched violently. Temperatures surged by at least 5 degrees Celsius in less than 20,000 years. Blink in geological terms. Carbon levels spiked. Oceans acidified. Forests migrated. Many deep-sea species perished. The cause remains debated. Volcanism could explain it: massive eruptions flooding the air with carbon dioxide. Others point to methane hydrates, vast frozen reserves in ocean floors suddenly released. Yet to test the Silurian hypothesis is to ask, could this have been the echo of something else? Could this carbon spike, so sudden and so extreme, be the chemical ghost of an ancient industry? It is not the only anomaly. In the Cretaceous, before the asteroid struck, there were other warming pulses. In the Permian, long before the rise of dinosaurs, life nearly ended in the greatest extinction of all time. Each of these events has explanations: volcanoes, impacts, tectonics, but the completeness of those explanations is not certain. Gaps remain. Mysteries linger. And into those gaps slips the haunting possibility. Perhaps what we see are the shadows of something forgotten, erased yet not entirely gone. This does not mean ancient cities lie beneath our feet. Geology is clear: after millions of years, physical artifacts vanish. But in the chemistry of the rocks, in the isotopic ratios and extinction pulses, lie potential red flags. If a civilization existed, its passing would resemble a natural catastrophe, indistinguishable unless we ask the question. And so the work becomes one of subtlety. Scientists read sediments like detectives reading ashes. They search for patterns too fast, too sharp, too artificial to be natural. They compare them with what humanity is now leaving behind: plastics, isotopes, fertilizers, extinctions. Our legacy is the blueprint of what to search for in the past. It is a humbling pursuit, for it forces us to recognize the impermanence of our own world. 100 million years from now, there will be no New York, no Paris, no Beijing, no Cairo. There will be no monuments, no names, but there will be a thin layer in stone, a chemical anomaly, a sudden extinction, a whisper that something lived, built, and changed the earth before vanishing. And if such a whisper exists already, it's buried in the rock, then humanity is not the first to walk this path. Others may have come long forgotten, their legacy reduced to a few odd ratios of carbon and a scar of vanished life. The rocks do not lie. But they do not speak clearly either. They speak in fragments, in riddles, in hints. To hear them requires humility, patience, and imagination. And when we listen, we must accept the most haunting possibility of all: that silence does not mean solitude. The earth may have hosted more than one story of intelligence. Ours may be only the latest, another, lying soon to be buried beneath the stone. 55 million years ago, the earth changed with alarming speed. The seas warmed, the skies thickened, and the biosphere trembled. Scientists call this moment the Paleocene thermal maximum, the PETM. It was an upheaval of climate. Unlike almost anything else in the fossil record, a fever that gripped the planet and left scars in stone. Temperatures surged by at least 5 degrees Celsius in less than 20,000 years. A blink. Geologically speaking, the deep oceans turned acidic, dissolving shells and wiping out entire families of organisms. Mammals on land shrank in size, perhaps forced to adapt to a hotter, harsher world. Forests migrated toward the poles. It was a planetary reconfiguration, rapid and destabilizing, as if the Earth itself had inhaled a vast breath of carbon and could not exhale. But what lit this fire? Volcanoes may have erupted in great fury, belching carbon dioxide into the sky. Methane clathrates frozen reserves of carbon buried in ocean sediments may have thawed suddenly, releasing gas in torrents. Others suggest shifts in ocean circulation, subtle but profound, to stabilize the carbon balance. Each explanation carries weight, yet none fully closes the case. The pet remains an open question, a mystery written in isotopes and extinction. And here, in this gap of certainty, emerges the unsettling shadow raised by the Silurian hypothesis. If humanity today drives a sudden spike of carbon into the air, warming oceans, shrinking species, collapsing ecosystems, then what distinguishes our footprint from what we see in the PTM? If an industrial civilization had existed before us, releasing greenhouse gases at scale, would it not appear precisely like this in the record? A sudden warming, surge of carbon? An ecological crisis. The rocks whisper anomalies beyond the PTM. There are other warming pulses, sudden and sharp, scattered across deep time. There are isotope irregularities, chemical fingerprints that suggest massive and unexplained releases of carbon or methane. There are layers that record acidified seas, in which coral-like organisms collapse and vanish. These events are usually attributed to natural forces, volcanoes, tectonics, asteroid strikes. Yet the Silurian hypothesis asks, are we certain? Or are we simply conditioned to assume nature alone? The unsettling scale of erasure deepens the mystery. Earth is not a stable archive. It is a restless recycler swallowing its own past through. The slow grind of plate tectonics, ocean crust, no matter how ancient, rarely survives more than 200 million years before being dragged beneath continents and melted back into the mantle. Entire epochs vanish in this way, their evidence consumed. Even continents are not safe. Erosion strips them, glaciers grind them, winds sculpt them to nothing. To search for ancient civilizations is to search in the ruins of a library that has burned and rewritten itself countless times. Against this backdrop, the silence of the record is no comfort. It is not proof of absence, only a reflection of how little survives. If another civilization had thrived in the Eocene or the Cretaceous, its monuments would already be gone. Its artifacts would already be dust. What might remain are only the echoes, a sudden warming, a chemical scar, a mass extinction, and those we already see. This possibility is not declared as fact. Science does not claim the PTM was driven by industry, nor that methane pulses were the exhaust of machines. But the symmetry is undeniable. Our own age provides a mirror, a guide to what such a civilization's disappearance might look like. In studying our own impact, we learn how to recognize the echoes of others, and it is here that humanity confronts its arrogance. For centuries, we have assumed we are unique, the first intelligence to build and alter the planet we have seen. Ourselves as the pinnacle of an evolutionary climb, the final inheritors of a silent Earth. But deep time mocks this certainty. It shows us how brief our story has been, how fragile our monuments, how easy it is to vanish without a trace. Perhaps intelligence has walked this path before. Perhaps others rose, built, and fell, leaving behind only the faintest of scars. To imagine this is to step into humility. The Earth does not care for memory. It does not enshrine its civilizations. It buries them, recycles them, erases them with glaciers and oceans, with tectonic churn and chemical weathering. What is left to us are anomalies, mysteries, like the PTM where the planet shifted with unnatural speed. We can explain them with nature, but we cannot be certain we are not hearing the echoes of something more. This is the escalation of the mystery. The record already holds events indistinguishable from the scars we are now leaving, that our own age, if studied 50 million years hence, might look no different from the PTM, that we may not be unique, only fortunate enough to survive long enough to wonder. In the silence of stone, the past becomes unknowable. But the questions it leaves behind are profound. Did intelligence walk here before us? Were there others who warmed the seas, shifted the carbon, and drove extinctions only to vanish into oblivion? And if so, does that not mirror our own precarious path? The Earth remembers but faintly. Its memory is etched not in monuments but in anomalies. And in those anomalies, the mystery deepens. The rocks are silent, but their silence is not without questions. For within the fragments of Earth's ancient story lie patterns of destruction and renewal. Sudden spikes of carbon, abrupt extinctions, and climates that lurch from one equilibrium to another. Each anomaly demands an explanation. And for centuries, science has answered in the language of natural forces: volcanoes, impacts, methane releases. Yet the Silurian hypothesis whispers another possibility. What if some of these scars were not entirely natural? What if they were the faint echoes of intelligence, erased by the indifference of time? The natural explanations are formidable, grounded in evidence. Volcanism has always reshaped the world. In the Permian period, 250 million years ago, vast eruptions flooded what is now Siberia with molten rock. The Siberian traps unleashed torrents of carbon dioxide and sulfur, choking the atmosphere, poisoning the seas, and driving the most severe extinction in Earth's history. More than 90% of species vanished. Such power needs no civilization to ignite it. Asteroid impacts, too, carry apocalyptic weight. 66 million years ago, a mountain-sized rock struck the Yucatan, carving the Chicxulub crater and ending the reign of dinosaurs. The impact hurled dust and sulfur into the sky, plunging Earth into darkness, shutting down photosynthesis, and collapsing ecosystems in weeks. A single asteroid accomplished what no industry could, and then there are the oceans themselves, holding secrets of collapse. Methane clathrates crystals of water and gas buried deep beneath the seafloor wait like frozen bombs. When destabilized by warming, they release methane in surges far stronger than carbon dioxide. Some scientists suspect these reserves triggered ancient warming events, transforming the atmosphere and reshaping life. In this model, the Earth itself is both culprit and victim, releasing its buried fire in sudden breaths. These explanations are persuasive. They show us how a planet can stagger and collapse without the hand of intelligence. Yet they do not close the case entirely. For the chemical record of events like the Paleocene-Eocene thermal maximum still bears an uncanny resemblance to what humanity is now creating. The sudden carbon release, the global warming, the acidified seas, these are precisely the scars of industry. To dismiss entirely the artificial possibility is to assume humanity is unique. No other intelligence has ever walked this path. The artificial explanation carries its own unsettling weight. If an industrial civilization once rose, it would have burned fuels, altered chemistry, and spread compounds that nature could not make alone. Perhaps it, too, would have driven a mass extinction, reshaping life before vanishing itself. Such a civilization might even have experimented with synthetic molecules, long-lived compounds alien to Earth's natural chemistry. If traces of these persist in sediments, they could be the fingerprints of the forgotten. And there are darker speculations still. Perhaps intelligence, once risen, does not merely consume, but also tries to control. Could a vanished species have attempted terraforming, deliberately altering climate, oceans, or atmosphere in an effort to stabilize or exploit? If so, the boundary between natural and artificial becomes blurred. The record would show only sudden change, not its intent. Was it volcano, accident, or design? The rocks cannot tell us. They speak in scars, not in motives. The speculation grows stranger when biology itself is considered. Could intelligence have emerged not from primates, but from lineages long erased? Mammal-like reptiles flourishing in the Permian showed complex behavior and physiology. Some stood upright, some had differentiated teeth, some nurtured their young. Given millions more years, could one branch have achieved more? Or consider the dinosaurs themselves. For over 150 million years, they reigned in every corner of the planet. Among them were species with large brains relative to their bodies, sharp vision, and grasping hands. Could evolution, given time, have produced something far beyond them, creatures that reasoned, planned, and built? One speculation even suggests that intelligence may not be rare but cyclical, that the rise of industrial civilization is not a unique accident, but a pattern that can repeat whenever conditions allow. Species rise, develop tools, burn fuels, alter climates, and ultimately collapse, siege, leaving faint chemical scars before vanishing into silence. If this is true, then humanity is not the first, nor will it be the last. We are only one iteration in a repeating cycle, one fragile bloom in the deep garden of time. This paradox confronts us with humility. Intelligence feels monumental from iterate within, yet from the perspective of geology, it may be only another temporary flourish. Civilizations may rise like waves and fall like foam, each erased, each forgotten, each indistinguishable from the natural catastrophes that litter Earth's history. To imagine this is to stand at the edge of a vast abyss, where memory dissolves and only silence remains. And yet in the silence, we are compelled to speculate. For speculation is not fantasy, is the extension of science into possibility. By considering artificial causes, scientists sharpen their understanding of natural ones. By imagining past civilizations, they learn how to detect their own fingerprints in the record. The Silurian Hypothesis does not insist on ancient builders. It insists only that we recognize the limits of certainty, that in the abyss of deep time, absence is not proof. Theories abound, natural and artificial, volcanic and industrial, each incomplete yet suggestive. And in their tension lies the haunting truth. Whether the scars we see were carved by nature or by forgotten hands, the outcome is the same. Life was shaken, climate shifted, species vanished. The planet endured, but civilizations, if they existed, did not. The Earth is patient. It erases, it forgets, swallows mountains and exhales oceans. Against such power, intelligence may be fragile, temporary, and endlessly replaceable. Paradox is this: life may evolve intelligence again and again, but time itself ensures that almost nothing remains, and so the mystery deepens, not with answers, but with questions. Were there others before us? Did they build, burn, and vanish? Or are the scars we see the pure work of a restless planet? In the silence of stone, we cannot yet decide. But in asking, we confront the possibility that humanity is not alone in its path, only alone in its memory. If the rocks of Earth carry secrets, then science becomes the lantern to read them. But the lantern is faint, and the script is fragmented. The Silurian Hypothesis, unsettling as it is, presses scientists to ask, how do we distinguish the scars of nature from the fingerprints of intelligence? The answer lies not in imagination, but in tools, delicate, patient, and relentless instruments that probe the chemistry of stone, the memory of ice, and the whispers of the deep sea. One of the most powerful of these tools is isotope analysis. In every atom lies a subtle variation, different weights of carbon, oxygen, nitrogen, sulfur, teeny differences that act like tracers through time. When life thrives, when climates shift, when volcanoes erupt, these isotopes rearrange themselves in measurable ways. By studying the ratios of carbon-12 to carbon-13, or oxygen-16 to oxygen-18, scientists can reconstruct ancient climates, charting the rise and fall of heat and cold, abundance and scarcity. It is in these ratios that the anomalies of the Paleocene-Eocene thermal maximum are revealed. A sudden, steep tilt in the balance, as though something had pumped vast amounts of light carbon into the air. In Antarctica and Greenland, ice cores serve as frozen chronicles. Each year snow falls and compacts, trapping bubbles of atmosphere within layers of ice. By drilling deep into these frozen archives, scientists retrieve air that has been sealed for hundreds of thousands of years. Within those bubbles lie direct samples of ancient atmospheres, snapshots of carbon dioxide, methane, and other gases that shaped climates long before humans walked the earth. The deepest cores speak with voices from nearly 2 million years ago, and though they cannot reach as far as the PETM, they show the rhythm of natural cycles, delicate dance of ice ages and warm periods. Against this backdrop, humanity's sudden surge of greenhouse gases appears as a jarring spike, a deviation so sharp it dwarfs natural variation. Beyond the poles, the oceans themselves hold longer memories. Sediments drift to the seafloor year by year, layering upon each other, building archives of chemistry and biology. To study them, scientists launched the International Ocean Discovery Program, a global effort to drill deep into the seabed and retrieve cores that stretch back tens of millions of years. Within these columns of mud and stone lie fossils of microscopic plankton, the chemical fingerprints of seawater, and the isotopic echoes of carbon and oxygen shifts. These cores reveal when oceans acidified, when ecosystems collapsed, when climates tipped. They are the closest we have to a time machine, drilling not into rock but into memory. And then there is the eye from above satellites, scanning the surface of the Earth with radar, LiDAR, and hyperspectral imaging. They map the crust, measure deforestation, track desertification, and chart the rise of seas. Though satellites cannot reach into deep time, they provide a crucial mirror by observing how human activity alters Earth in the present. Scientists learn what signatures such activity might leave in the geological record. Deforestation leaves sharp boundaries in soils. Mining scrapes vast scars across landscapes. Urbanization changes albedo, the reflectivity of the surface. All of these, though ephemeral, become lessons in what to search for in stone. The work does not stop at Earth. For the Silurian Hypothesis is not only about the past of this planet, it is also about the search for life elsewhere. If civilizations rise and fall, if their signatures are chemical rather than monumental, then the tools we use here become guides for exploring other worlds. Astrobiology, the science of life beyond Earth, takes the same methods of isotope analysis and spectral signatures and applies them to Mars, to Europa, to Titan, to distant exoplanets orbiting alien suns. If ancient civilizations once walked Earth and were erased, then perhaps other planets bear the same faint traces: climate anomalies, chemical disequilibria, atmospheric scars. CERN, the great particle physics laboratory, contributes in a subtler way. By studying isotopes with extraordinary precision, physicists refine our ability to detect minute anomalies. Some isotopes decay slowly over millions of years, leaving daughter products that can be measured. These subtle ratios help geologists distinguish between natural processes and extraordinary ones. If a layer of rock bears an isotopic signature, outside known volcanic or cosmic events, it raises the question, what could have caused it? The tools of high-energy physics become, unexpectedly, tools for archaeology on the scale of planets. NASA's climate models, too, play their role. Originally built to forecast Earth's future, they can be turned backward, reconstructing climates of the past. By feeding in isotopic data, ocean currents, and solar cycles, scientists test hypotheses of ancient warming events. Was the PETME purely volcanic, or did it require another trigger? Could methane alone explain the speed, or is something missing? Each simulation sharpens our understanding, narrowing possibilities, exposing gaps. In those gaps lies the tension, the distinction between natural, catastrophe, and something else. Yet the challenge remains immense. Natural cycles are vast and chaotic. Volcanism can mimic industrial emissions. Asteroid impacts can trigger extinctions that look like ecological collapses. Methane releases can alter isotopes in ways indistinguishable from burning coal or oil. The deeper one looks, the harder it becomes to separate the artificial from the natural. The planet's record is ambiguous, its voice muffled by time. Still, science presses forward. Each anomaly is tested, each isotope measured, each core drilled. And though certainty remains elusive, the very act of searching carries profound significance. For by asking whether ancient civilizations once existed, scientists refine their ability to detect civilizations elsewhere. If we cannot distinguish between natural and artificial on Earth, how can we hope to read the atmospheres of exoplanets, hundreds of light years away? If the PETME could be mistaken for industry, then industry on another world could be mistaken for volcanism. The search for extraterrestrial life becomes bound to the humility of understanding our own planet's scars. The Silurian hypothesis thus expands the scope of science. It does not claim ancient cities lurk beneath the crust, it claims only that The tools we use to study the past must be sharpened by imagination. That in the isotopes, the sediments, the atmospheres of worlds, there may be signs we are not alone, not in space, not even in time. In the laboratories of isotope analysis, in the frozen vaults of ice cores, in the drilling ships of the open seas, and in the silent eyes of satellites, the work continues. Piece by piece, the puzzle of Earth is reconstructed. Each fragment is fragile, each interpretation uncertain, yet together they form a narrative of a planet forever changing, forever erasing, forever whispering. The challenge is not only scientific but philosophical. How does one prove the absence of something in a record designed to forget? How does one distinguish between catastrophe and civilization, between fire from within and fire from hands? The answer may never be certain, but the act of asking transforms science itself. It's panning its gaze from the surface of Earth to the cosmos, from the present to the deep corridors of time. Perhaps, in the end, this is the true legacy of the Silurian Hypothesis. Not proof of ancient civilizations, but a sharpening of our vision, a reminder of humility, a deepened awareness of the immense fragility of our own record. For if we vanish, as others might have, our story too will be left in isotopes, sediments, and scars. The tools we build today to search for others are the same tools that will one day search for us. The night sky is a paradox, is filled with countless stars, each with planets circling in silent orbits. Many of those planets, by the numbers, should be habitable. Some should host oceans, atmospheres, and life. Few should have nurtured intelligence. And yet, when we listen, the cosmos is silent. No signals reach us, no messages arrive, no civilizations announce themselves. This is the Fermi paradox. In a universe that should be teeming with voices, why do we hear none? The Silurian Hypothesis offers one reflection in this mirror. If intelligence has walked Earth before us and been erased, then perhaps the same is true on other worlds. Civilizations may not endure, may rise, flourish, alter their planets, and then vanish, leaving behind only the faintest scars. To search for them across the stars is to search for what time itself does its best to erase. The silence of the cosmos may not mean it is empty. It may mean it is impermanent. Earth becomes a test case. If we cannot detect our own possible predecessors in the strata of our planet, if even here the record of civilization dissolves into ambiguity, then how can we expect to detect alien civilizations across light years of space? The geochemical scars of industry, subtle even beneath our feet, would be nearly impossible to distinguish in the thin spectral lines of exoplanet atmospheres. If intelligence leaves only whispers on its home world, its echoes across the cosmos will be even fainter, and yet science presses outward. Telescopes, such as the James Webb Space Telescope, scan the skies, searching for exoplanets whose atmospheres show disequilibria gases out of balance, hinting at processes beyond the natural, oxygen mixed with methane, carbon dioxide patterns that resist geological explanation. These are the fingerprints we might detect, the same ones we leave on Earth today. But if civilizations rise and fall quickly, their chemical signatures may be fleeting. A planet may glow with the light of industry for 1,000 years, then fade back into silence for millions. The odds of catching such a moment are slim. Consider, too, the timescales. Stars burn for billions of years, but civilizations may last only thousands. The window of detectability may be narrower than a human heartbeat compared to cosmic time. So, the cosmos could host countless civilizations, each flaring like sparks in the dark. Never overlapping, never hearing one another. The silence we perceive is not emptiness, but the vastness of time itself. This thought reshapes the Fermi paradox. Perhaps the reason we do not hear others is not that life is rare, nor that intelligence is unique, but that survival is fragile. Civilizations may burn bright, but briefly. They may consume their resources, destabilize their climates, or fall victim to the same indifference of geology that erases their memory. Their monuments may vanish, their signals fade, their worlds reset. Across billions of years, intelligence could rise again and again, Yet each iteration may be only a wave swallowed by the sea. The Silurian hypothesis extends this reflection further. If Earth itself may have hosted multiple civilizations, none leaving clear evidence, then the absence of proof elsewhere is unsurprising. If even our own planet hides its past beneath erosion and subduction, then alien worlds will hide theirs. As well, the cosmos may be alive with stories, but time erases its books faster than we can read them. And so, what we call the Great Silence may be nothing more than the natural rhythm of impermanence. Industrial civilizations may not last long enough to spread across the galaxy. They may not endure to build interstellar empires, to construct beacons that shine for millions of years. Instead, they may collapse back into silence before they can leave detectable traces. The Milky Way could be filled with the ruins of forgotten civilizations, each erased by time, each leaving behind only the faintest of anomalies in the chemistry of their planets. The implication is haunting. Humanity's dream of contact, of joining a community of minds among the stars, may be nothing more than a mirage. We may listen forever and hear only silence, not because we are alone, but because others have already come and gone. The cosmos is not empty, but transient. Civilizations flicker in and out of existence, separated by gulfs of time too vast to bridge, and yet this reflection is not without meaning. For if civilizations vanish quickly, then survival becomes the rarest of achievements. To endure is not inevitably, is extraordinary. If we are to avoid joining the silence, we must learn from the scars of the past, both our own and those etched into the rocks of Earth. The lesson is humility, that intelligence is fragile, that the planet endures beyond its civilizations, and that survival requires harmony rather than conquest. The cosmic mirror shows us two truths at once. First, that we may not be unique, that others may have risen before us, both on Earth and across the stars. And second, that our future is uncertain, that without care, we too may vanish, leaving only whispers in stone and silence in the sky. The night sky remains quiet, but in that quiet is not despair, but reflection. Perhaps we listen not to hear others, but to recognize ourselves. Perhaps the silence of the cosmos is the echo of impermanence, reminding us of what is at stake. For in the end, the greatest mystery may not be whether we are alone, but whether we can endure long enough to be heard. Beneath every step humanity takes lies the weight of ages. The ground carries memories older than memory itself, stories pressed into stone by time's unyielding hand. And in that silence, the Silurian hypothesis whispers its humility. Humanity is not the inevitable summit of Earth's story, but a fragile newcomer. Late to a stage already scarred by forgotten performances, the thought is disquieting. We build as though permanence were ours, cities rising toward the clouds, monuments carved to defy centuries. Yet Earth has seen mountains crumble, oceans rise and vanish, continents torn and scattered. Civilizations, should they have existed, before us would have believed as we do that their works would endure, that their voices would echo. But time is merciless. It erases, it recycles. It folds stone upon stone until memory becomes indistinguishable from silence. The Silurian hypothesis offers no evidence of forgotten builders, no proof of vanished empires. Instead, it confronts humanity with perspective. It asks whether our story is unique, or merely another bloom in a geological springtime. Like flowers, civilizations may open briefly, radiant with energy and creation, only to fade and return to the soil. Each bloom is unaware of the blossoms before it, convinced of its singularity. Yet the meadow of time may have carried many such seasons, each erased before the next began. To imagine this is to recognize our fragility. Intelligence, though vast in its imagination, is fleeting in its endurance. The Earth is patient. It can host countless experiments in life, countless blooms of complexity, countless trials of intelligence. But patience is not kindness. The planet does not preserve, does not remember. It offers the stage, but does not keep the script. Civilizations must write their stories knowing that time itself conspires to erase them. What then is the meaning? of this silence? If others walked this earth before us, what warnings did they leave? Perhaps none. Perhaps their traces are only chemical anomalies buried in stone, indistinguishable from volcanism or methane release. Perhaps their sole message is absence, a void where memory should be, a silence meant to remind us of how easily greatness dissolves. Yet even that silence speaks. It tells us that impermanence is the rule, not the exception. It tells us that intelligence does not guarantee survival. That industry does not promise permanence. It reminds us that our own moment, the Anthropocene, marked already by carbon spikes, plastics, isotopes, and extinctions, will one day be judged not by our monuments, but by our impact on the planet's chemistry. If another intelligence arises, after us, it may find only our scars, puzzling over them as we puzzle over the pet. Uncertain whether they mark nature or civilization, the humility of this perspective is profound. It strips away the illusion of uniqueness, forcing us to see ourselves as part of a cycle larger than any one species. Civilizations may rise not once, but many times, each vanishing into silence, each convinced of its singularity, each leaving only whispers in stone. We may not be the first, we may not be the last, and yet within this humility lies both warning and hope. If impermanence is the rule, then survival requires something re-ran intelligence capable of seeing beyond its own arrogance, one willing to listen to the silence and learn from it. Perhaps those before us failed to do so. Perhaps that is why they are gone. The question is whether we will follow the same path, or whether we will find a way to endure beyond the silence. In this reflection lies the most haunting of questions. If others walked this earth before us, what lessons did their vanishing hold? Did they burn too brightly, consuming their world until it turned against them? Did they alter their climate beyond repair, as we are beginning to? Did they believe themselves immune to time, only to discover its indifference too late? Their silence is the answer, but it is an answer open to interpretation. We can treat it as inevitability or as warning. The closing image is not one of despair, but of awe. The Earth's rocks hold secrets deeper than memory, waiting for someone to read them. In their layers lie the scars of extinctions, the pulses of carbon, the migrations of forests, the echoes of upheavals that reshaped the planet. Whether those scars are purely natural or partly artificial, they remind us of our place. We are not outside of time, but within it. Not eternal, but ephemeral. The Silurian Hypothesis, in the end, is not about vanished civilizations. It is about humility. It asks us to see ourselves against the backdrop of 4.5 billion years, to understand how small our moment is, how fragile our permanence. It is an invitation to reflection, a reminder that survival is not guaranteed, and that memory is not owed. Civilizations may bloom and fade like flowers in geological springtimes. Humanity is one such bloom, radiant but vulnerable. Whether we endure or vanish depends on whether we listen to the rocks, to the silence, to the warnings etched into deep time. And so the final question remains: will we hear them? Or will we, too, vanish into the quiet, leaving only whispers in stone for others to puzzle over millions of years from now?